Hello dear friends, welcome to our program for chemistry, third secondary stage. Today we have another session about revision. We have different types of question, we have different methods to answer these questions. Let's go to see and concentrate with me very well to get high marks in your exam. Let's go. Draw the structure of anything you have in your curriculum. We have some kind of cells, we have some kind of devices, we have many things like this. So we can draw it in a right way to make what? To make the labels and to know the function of each part here. So draw the structure of dry cell with labels. Any one of these devices or these shapes or figures must have labels. Why? Because you must know the labels of each part or the name of each part and its function. Revise this very well. Remember this very well. So draw the structure. The question here, we have the structure of the dry cell with labels and write the total equation of its reaction. Let's go to see this one. Dry cell. What's meant by dry cell? Dry cell, it is like this. We have a case and it contains many things inside. Number one, we have carbon root, we have spacer, we have ZnCl2 and MnO2 and NH4Cl, and we have zinc anode. What's meant by this? We have a case. Dry cell, it is a device that used to operate some toys or some tools by what? By changing chemical energy to electric energy. So we have some chemical compound inside this dry cell. So the carbon root, it's found here as what? As a positive pole. So the spacer between them, between what? Between carbon root and what? And ZnCl2, it is white paste here. White paste, it means zinc chloride mixed with manganese dioxide, mixed with ammonium chloride. So the ammonium chloride is what? Is the electrolyte here. So, and zinc anode here, it makes what? It makes the case of dry cell. So here, the total spontaneous reaction in the dry cell, it's what? Is the summation of the two halves of the cell reaction. This cell gives EMF what? EMF equal 1.5 volts. So here, the total equation or total voltage of this one, of this cell, it gives us 1.5 volts. After that, the total reaction will be as a following. It's very important to know the total reaction of each cell, dry cell, galvanic cell, Daniell cell, mercury cell, any one of these cells, you must know this reaction. So it is very important to write it in your exam. So here, the total reaction will be as the following. Zn plus 2MnO2 plus NH4, ammonium chloride or ammonium ion, give us what? Give us Zn plus 2. It means the ion, the zinc, change from zinc metal to ions. And we have 2MnOOH plus what? Plus NH3. So after using this dry cell, we have what? We have this chemical reaction. It's a reversible reaction that makes what? That makes ammonia gas produced. So it stops the reaction between these compounds and doesn't produce any type of electric energy. So here this is irreversible reaction, it is complete reaction, it is not a charged again. So Zn plus MnO2 manganese dioxide plus NH4 positive 1 or NH4Cl give us what? Give us zinc positive 2, it is ion of zinc, and we have MnOOH plus what? Plus NH3 as evolve. Let's go to see another one. Draw the structure of mercury cell. It's very important to know each one of them with labels also and write the total equation of each reaction. Let's go to see this one. So the mercury cell, what is the shape here? It's manufactured in the shape of cylinder or disc, and it is used in earphones and clocks and many small toys. And here we have the shape of the mercury cell. So it's what? It is a metal case and it contains some chemical compounds. What are the chemical compounds here? that found in this one, it consists of negative pole of anode of zinc, positive pole or cathode of mercury oxide HgO and graphite, and here we have the electrolyte of KOH. So here we have many types of parts or many parts that found in this one. So negative pole or anode of zinc case. And after that, positive pole or cathode of mercury oxide HgO and mixed with graphite. So the electrolyte of KOH is KOH. After that, we have the shape. We must draw it in this right way. So the metal cap and the anode, and we have the cathode. Anode, it means what? It means like this. It's what? It's the negative pole of zinc. And we have the positive pole of cathode of mercury oxide. This mercury oxide is found what? It's found in the cathode inside in the blue color. So here the cathode is HgO. Because what? We have the chemical change, chemical energy changes into what? Changes into electric energy. So the metal cap here, and we have anode and we have cathode. After that, we have this one. Total reaction occurring in this mercury cell is what? Is zinc metal plus HgO. So the zinc is more active than mercury, so it change into zinc oxide and mercury. This is the first one. Second one, we have what? We have here, this is what? The second one, EMF equal 1.35 volts. So we have one reaction or total reaction that happened here. We have zinc that change or react with mercury oxide that give us zinc oxide and plus what? Plus mercury here. After that, we have another one. We have how can copper purified? Purified by electrolysis. We have electrolysis also here to make what? To make purification of some kind of metals like copper. So the electrolysis is used to remove any impurities from the copper so that it's pure enough for making electrical wires. Let's go to see this one. Here we have the commercial copper, and here we have a rod of pure copper. This pure copper, it's negative pole, and we have the commercial copper, it's what? It's the positive pole, and here we have a battery and wires and key. So after that, positive electrode is impure copper. Impure copper, it means a commercial. It contains some kind of what? Some kind of material or metals, okay? That's what? That's unwanted. So the positive electrode is impure copper, the negative electrode is pure copper. So the electrolyte is copper sulfate solution. Why? To make motion of these ions here from the positive to negative, and from negative to positive through what? Through the copper sulfate solution. Let's go to see the stage 2. We have, if you move or we close this circuit, so here these impurities or the parts of impurities that move out, and the mass of this electrode, it decreases. Why? Because the ions here to get bigger, and it's coated with the copper, the other one increase in its mass and volume, because its mud forms at the bottom of the vessel. What's happening in the electrodes? Let's see here. So the copper that move from its compound inside the electrolysis or electrolyte to collect what? To collect on what? On the negative rod. Why? Because it gain 2 electrons and it change it into copper atoms. So the copper, it's what? It collected at the negative pole of what? Of this rod. But we have in the other one, we have the copper that's lose these electrons and they change it into ions moving inside what? Inside the electrolyte. So each copper positive 2 gains 2 electrons to form a copper atom which sticks to the electrode, and this reduction. This is what? This is a reduction. Because this is reduction, it means what? It means gaining electrons. And after that, in the other part, we have the copper atoms in the positive electrode can lose 2 electrons to form copper ions, copper positive 2, which dissolve into the electrolyte. This is oxidation process. Why? Because it is losing electrons. So why does a mud form below this electrode? The mud is formed here because we have some kind of metals: gold, sodium, silver, platinum, anything of these things or impurities that found in the copper here to make what? To make it becomes free. So the mud they formed collected as may contain silver and gold. So I don't need silver and gold from this because I need a pure copper to precipitate or to make what? To make the pure copper that formed by electrolysis. It is very easy to make this and it is very easy to use it in industry. So the copper purified by electrolysis. We have some questions about this. We have this statement about purification of copper. True or false? This positive electrode is made of impure copper. Positive electrode, it's what? It is impure copper. Yes, it's very good. It is true. Gold is formed as a negative electrode. We have no gold. It is from impurities. So it is false, right? After that, number 3, the positive electrode dissolved during this process. Positive electrodes dissolves during this process. It's what? It's true. Why? Because this one, it has what? It has decreasing of the mass many times during this reaction to form atoms of copper that precipitate on the negative charge or the negative pole. Again, we have number 4, the slag. Slag is valuable because it contains silver and gold. It's what? It's true. Yes, here we have true. Why? Because it's what? The mud. It contains silver and gold, so it moves down without any reaction. Why? Because silver and gold, they are inactive elements. So 3 electrons that needed to turn Cu positive to ion into copper. No, it's false. Why? Because copper, it needs what? It needs 2 electrons to change into copper atom. In the last one, we have the reduction. Reduction takes place in the positive electrode. This is what? Reduction. It takes place in the positive electrode. This is what? This is false. So here we have this is false. Why? Because reduction, it takes place at negative electrode. After this one, we have another part of questions. It's about carboxylic acid. Carboxylic acid, it is a type of organic compound. Complete these reactions. So here we have lithium hydroxide that gives us lithium, ethanoate, and water. So hydroxide, and here we have ethanoate. Which one of these types of compound? That's what that's called. That's here. We have here, this is what? This is magnesium ethanoate or magnesium or ethanoic acid or many things of this. We have hydroxide here that make ethanoate, lithium hydroxide. To make lithium ethanoate, so I have what? I have here calcium ethanoate. To make what? To make this reaction between lithium and calcium. So here. After that we have iron 2 hydroxide, so we have iron 2 methanoate. Iron 2 methanoate, I need what? I need, this is methanoate. Here we have which one here? We have the calcium ethanoate, magnesium ethanoate. Which one that makes iron hydroxide that replace this one? So here we have sodium, we have any one of them, we have magnesium ethanoate. After that we have ethanoic acid and calcium carbonate. This is acid and carbonate. Which one that form here? So here we have carbon dioxide and water, but here we have what? We have many salts. So ethanoic acid and calcium carbonate, so we have calcium ethanoate. After that we have ethanoic acid with magnesium. It's what? Ethanoic acid and magnesium. So we have here, this is magnesium ethanoate and what? And hydrogen that move out. After that we have propanoic acid. Propanoic acid with zinc, we have zinc propanoate. Zinc what? Zinc propanoate. Why? Because zinc here substitute the hydrogen from this compound. Let's go to see this one. Here we have complete the equation. Start the chemical equations here and the chemical formula to complete the equation. So here we have this one, it's formic acid plus what? Give us HCOOLi. We have here which one of them? LiOH, LiHO, LiO2. We have LiOH. Why? So here this is LiOH. Why? Because formic acid plus LiOH give us HCOOLi or Na or magnesium. Why? Because any type of carboxylic acid that react with metals, we have a salt here. After that, we have here CH3COOH plus NaOH. It is acid and base. Give us CH3COONa plus what? Plus H2. So here H2O, because what? Because water here, it's one of the products between the acid and base. Let's go to see another one. Here we have CH3COOH. Which one that makes sodium ethanoate? So here we have this one. This is what? This is carbon dioxide and water. So which one is right? Here we have this one, Na2CO3. It's sodium carbonate. To make what? To make reaction between salt, between the acid and sodium carbonate, forming a salt and carbon dioxide and water. It's good to see another one about this type of compounds that called what? That called carboxylic acids. Here we have calcium carbonate plus CH3COOH. It gives us CH3COO by 2 Ca. So here, which gas that produced? We have carbon dioxide, like the last one. After this, we have CH3COOH plus Na. Give us what? Give us salt and water. Wrong. Why? Because here it is salt. Here we have Na, just Na, not NaOH. So here this is what? Replacing hydrogen here. So the hydrogen is right. So after that we have next. Which one with magnesium gives us what? CH3COO by 2 Mg plus H2. Which one here? We have CH3COOH or CH2COOH or any one of them. We have this one. Why? Because here this is the carboxylic acid that replaced the hydrogen by meaning what? By this magnesium atom to form salt, and the hydrogen evolved from this reaction. Here we have another type of questions here that called the problems. So the problem here, calculate the mass of half mole of water. It's from the first one or first unit here. So calculate the mass of 0.5 mole of water, and H equal 1 and O equal 16. If you don't write the compound in the right way, so we have no answer. So calculate the mass of 0.5 mole water. We have the answer here. 1 mole of water equal, you must calculate 1 mole of water in each one of these problems. 1 mole of water, H2O, equal 2 times 1 is 2 hydrogen plus 16, it is 1 oxygen, gives us what? Gives us 18 grams. So 1 mole of water contains 18 grams of these atoms. So here the 0.5 moles, that equal what? Equal 0.5 times 18, it gives us 9 grams. So the 9 grams here, it is half mole of water. Half mole of water, it makes what? In this one, it's 9 grams. Let's go to see another one or another problem. Calculate the number of molecules in 36 grams of water, and here we have H equal 1, O equal 16. It's very easy, but it's not difficult. Why? Because calculate the number of molecules, it means Avogadro's number. Excellent. So the Avogadro's number equals 6.02 times 10 power of 23 molecules or ions or atoms. So calculate the number of molecules of 36 grams of water. We must calculate 1 mole of water. How many grams in 1 mole of water? So 1 mole of water, it contains 16 plus 2 equal 18 grams. But the number of moles in 36 grams, how many moles in 36 grams? We have 36 divide 18, that called 2 moles. So 2 moles, it means what? It means here the number of atoms or the number of molecules that found in 2 moles of water that has what? That has 36 grams. Let's go to see this one. 1 mole of water equal what? Equal 6.02 times 10 power of 23 molecules. So the moles of water H2O equal what? Equal 2 times 6.02 times 10 power of 23 equal 12.04 times 10 power of 23 molecules. Don't forget this. When you have 1 mole of water, I calculate the number of molecules or the number of atoms or the number of ions. If I have the number of moles, not the number of grams, or the mass or volume or anything of this, I need to know the number of moles. So the number 1 mole of water equal what? Equal, or how many molecules in 1 mole of water? It's equal Avogadro's number, 6.02 times 10 power of 23 molecules. So 2 moles of water H2O equal 2 times Avogadro's number, 6.02 times 10 power of 23 equal what? Equal 12.0204 times 10 power of 23 molecules. We have drawn the structural formula of the following compounds. Here we have many compounds here, and what are the structure of each one? We have the structure and we have the names of each one. Here we have methane. Methane is CH4, the molecular formula CH4. So we have C in the center. Here we have C in the center, and we have 4 atoms of hydrogen that bonded with this carbon atom. Again, we have methane. It is alkane. So the alkane here, it means what? It means 1 carbon atom and 4 hydrogen atom that's what that bonded to each other, okay, to form 1 molecule of this one. Ethane. Ethane, it's C2H6. Here we have C2H6, C2, okay, and we have H2 and 1 here, so CH3, CH3. After that we have propane, propane 3C3H8. So here these 3 atoms of carbon, and we have many atoms of hydrogen, that we have 8 hydrogen atoms that bonded like this. This is called the structural formula here. And here we have molecular formula of each one of these compound, and this one, it's what? It's the name according to the IUPAC names. Here we have another exercise about esters. So we have what? We have some kind of this compound that called esters, and we have here, this is multiple choice. So what is the synthetic name of carboxylic acid that contain 2 carbon atoms? Carboxylic acid that contains 2 carbon atoms, it's what? Methanoic acid, or ethanoic acid, or citric acid, or lactic acid. We have 2 carbon atoms, so it is ethanoic. Yes, very good. It is ethanoic acid. It has 2 carbon atoms from one of them in the carboxylic group and the other one from the radical. Let's go to see another one. Which of these elements is not found in carboxylic acid? We have carbon, we have oxygen, we have hydrogen, we have sulfur. Which one it doesn't found, or it's not found in what? In this one. So we have sulfur here. After that, which one of these phases best describe the carboxylic acid? Which one of these properties is carboxylic acid? It is neutral? Wrong. It is acid. So it is strong acid? Also it's wrong. So we have weak acid, maybe strong alkali. Alkali, it's completely wrong. So we have this is weak acid. Why? Because it makes what? It makes reversible reaction between its ions and molecules. Because its form, it is weak acid, to decompose by itself into ions and collect itself again to form the molecules. So the molecules and its ions, they are found in the same test tube or the same medium of the reaction. After that, we have which produced if you add sodium carbonate to ethanoic acid. Which one that happened? Which thing or which compound that produced, which gas that produced if you add sodium carbonate to ethanoic acid? We have here sodium carbonate and acid. So carbon dioxide is right. Why? Because any carbonate with any acid forming carbon dioxide. Let's go to see another one. Which gas that produced from magnesium to ethanoic acid? Which one here? We have hydrogen here. Excellent. Why? Because magnesium is more active than hydrogen in ethanoic acid or any carboxylic acid to form what? To form a salt, and we have the hydrogen evolve from this reaction. After that, which carboxylic acid would you see to make the ester methyl ethanoate? Remember this. We have methyl ethanoate. We have two groups here. Methyl, that comes out from methyl alcohol, and we have ethanoate. Ethanoate comes out from the carboxylic acid. So the ethanoic acid, it's what? It is the carboxylic acid that we use, but we have methanoic acid is wrong. Why? Because this methyl group comes out from the alcohol. Next, what is the name of the salt made from reaction of sodium hydroxide with methanoic acid? So it is the name of this salt made to form what? Made from what? From the reaction of sodium hydroxide with methanoic acid. So which one here? It's the name of salt, sodium hydroxide and methanoic acid. So we have sodium methanoate is right. Why? Because it is the reaction between acid and alkali forming the salt methanoate, sodium methanoate, and water. After that, what is the ester typically used for? Used for what? Food coloring, or letter B, food flavoring, letter C, food packing, or D, food preservation. Which one? Food preservation, it's completely wrong. Why? Because this is a type of compounds that we use it for coloring or flavoring. Coloring is right. Wrong. It is wrong. Completely wrong. We have what? We have flavoring. We have the taste and smell of the compound or the food of our food that we use this type of compound that called esters. Next, we have another one, number 9. We have which of these compound is an ester? Ethanol or ethanoic acid, ethyl ethanoate, or lactic acid. So here, which one of these compound according to the IUPAC name? We have ethanol, it's alcohol. Ethanoic acid is carboxylic acid. And we have lactic acid, also it is carboxylic acid. We have what? We have ethyl ethanoate. We have this phrase "oate" that found in the last part of this one. Let's go to C. The last one here, we have number 10. What is the name of ester made of methanol and the propanoic acid? Methanol, that comes out, we have methane. So we have methyl. And the propanoic acid, we have propanoate. So methyl propanoate, that's produced from this one, and this is good answer and well done. So here we have many things about what? About the esters, to remember this very well and to answer these different types of questions about what? About esters many times. Dear friends, I hope to enjoy your time with us. Till we meet again in another session of revision of this curriculum of chemistry. Till we meet again, thank you and goodbye everybody.